reason why is because it's mathematics. That's all I need to say. So we're going to resume with trigonometric ratios. Trigonometric ratios. We only did one question last time, and we want to finish the whole set. So let's begin. In a triangle, two sides of length 3 and 5 enclose an angle of 120 degrees. Find the length of the third side. We'll use the cosine rule. A squared equals b squared plus c squared minus 2bc cosine A. And thus, the third side, named A, the square of its length is 3 squared add 5 squared, take 2 times 3 times 5 times the cosine of 120 degrees. And the cosine of 120 degrees is negative a half, and thus it becomes, on the right hand side of the cosine rule, 9 add 25 take 9 add 25 rather, plus 15 over 4. And 9 add 25 is 34. And 15 over 4 is 3.75. And thus we say 37.75. And 37.75, when square rooted, well, it's approximately 6.2, isn't it? Approximately 6.2. However, we need to be sure. In a triangle, two sides of length 3 and 5 enclose an angle of 120 degrees. Find the length of the third side. So yes, 9 add 25, which is 34, and then we have to take away a half times 3 times 5 times the cosine of 120 degrees. So yes, I think that's actually right, but that's strange. It should be a whole number of some kind. A triangle has sides of length 7, 8, and 13. Find the size of the angle enclosed by the sides of length 7 and 8. (49) adds 64 is 113. 169 take 113 is 56. And so 56 is negative a half times the cosine of the angle between them, and thus negative 28 is the cos. Hello. (56) is, yes, okay. 169 take 60. 64 at 49 is 113. 169 take 113 is 56. And then we have on the right hand side minus 28. Alright, so 56 has to be divided by minus 28. Okay, so, right, let's think this through. So the cosine rule says we have 169 on the left, 64 plus 49, take a half times 7 times 8 times the cosine of the angle between them. 64 at 49 is 113. Take that away from 169 and we have 56. And then we have minus 28 times the cosine of the angle between them is 56. Oh, I understand the error now. There should be a 2 there. Okay, let's do that again. Okay, so now it becomes simple. We have minus 112 times the cosine of the angle between them. And thus minus a half is the cosine of the angle. And so the answer is 120 degrees. Yep, and so we can fix question 2. In a triangle, two sides of length 3 and 5 enclose an angle of 120 degrees. Find the length of the third side. Okay, then a squared equals 3 squared add 5 squared. Take 2 times 3 times 5 times cosine of 120. Okay, so 9 and 25 is 34, and 34 take 30 times cosine of 120 is adding 15, and thus the answer, true answer is 7. The true answer is 7. Okay. Question 4. A triangle has sides of length 5, 6, and root 31. Find the size of the angle enclosed by the sides of length 5 and 6. Okay, root 31 is just a little bit over 5, but anyway, so we have 31 on the left, and then 25 and 36 on the right. 25 at 36 is 61. 61 takes 60 times the cosine of the angle between them is 31. And so the cosine of the angle between them has to clearly be 30. Or rather, beg your pardon, it has to be a half. It has to evaluate to a half. And thus it's 60 degrees. So yes, for the triangle whose sides are of length 5, 6 and root 31, the angle enclosed by the sides of length 5 and 6 is 60 degrees. A triangle has sides of length 2, 3 and 4. Find the exact cosine of its largest angle. Okay, that will be the side opposite the side of length 4, and so it will be enclosed by the sides of length 2 and 3. And so we have to say 4 squared equals 2 squared, add 3 squared, take 2 times 3 times 4 times the cosine of the angle between them. So 16 take 4 take 9 brings us down to 3, and then 3 equals negative 12 times the cosine of the angle. And so the cosine of the angle between them is negative 1/4. And so we say arc cosine of 1/4. Arc cosine of 1/4 for the angle between the two sides of length 2 and 3 and the triangle with sides of length 2, 3 and 4. Okay, great. Now the sine rule. In a triangle ABC, angle A is 30 degrees, angle B is 90 degrees, side A is 5, find the length of side B. Okay. Alright, so you can use the sine rule. So B over sine 90 equals 5 over sine 30. Sine of 90 is 1, so B is equal to 5 over sine 30, so B is equal to 10. Try again. In a triangle ABC, angle A is 45 degrees, angle B is 30 degrees, and side A is root 2. Find the length of side B. Okay, B over sine 30 equals root 2 over sine 45. So b over a half, in other words 2b, is equal to root 2 divided by root 2 over 2, which is equal to 2, and thus b is equal to 1. B is equal to 1. So in a triangle where angle A is 45 degrees, angle B is 30 degrees, and side A is root 2, side B is 1. Hello! In a triangle ABC, angle A is 30 degrees, side A is 6, side B is 6 root 2. Find the acute value of angle B. Okay, so sine A over A equals sine B over B. So sine of 30 degrees over 6 is equal to 6 root 2. Rather, sine of 30 degrees over 6 is equal to sine of B over 6 root 2. So a half over 6, that would be 1/12. So the answer is 45 degrees. So in the triangle ABC, where A is 30 degrees, side A is 6, side B is 6 root 2, the acute value of the angle B is 45 degrees. In a triangle ABC, angle A is 30 degrees, angle B is 45 degrees, side B is 4 root 2. Find the length of side A. Okay, so alright, let me try again. In a triangle ABC, angle A is 30 degrees, angle B is 45 degrees, side C is 4 root 2. Find the length of side A. Okay, so A over sine of 30 equals 4 root 2 over sine of 45. Now, sine of 30 is a half, and thus we have 2A on the left Sine of 45 is root 2 over 2, and thus we have 8 on the right, and so 8 over 2 is 4, so A is of length 4. So A is length 4 in the triangle ABC, where angle A is 30 degrees, angle B is 45 degrees, and side B is 4 root 2. Hello! In a triangle ABC, angle A is 30 degrees, side A is 4, side B is 4 root 3. Find the obtuse value of angle B. Okay, so we're going to use the sine rule. So sine B over B, sine A over A. And thus we have that sine B over 4 root 2 equals sine 30 over 4. Now sine 30 is a half, and so a half over 4 is an eighth. And then an eighth multiplied by 4 root 2 is root 2 over 2. And thus the obtuse value of angle B should be 135 degrees. So angle B is 135 degrees in the triangle ABC, where angle A is 30 degrees, A is 4, and B is 4 root 2. Oh no! That's incorrect. Alright, so we have to try again. In a triangle ABC, where angle A is 30 degrees, A is 4 and B is 4 root 3, find the obtuse value of angle B. So we're going to use the sine rule. Sine of B over B is equal to sine of A over A. And thus we say sine of B over 4 root 3 equals sine of 30 degrees over 4. Sine of 30 degrees over 4 is 1/8, and then an eighth multiplied by 4 root 3 gives us root 3 over 2. And thus the true answer is 120 degrees. Okay, next up, areas of triangles. Find the area of the triangle with sides of length 6 and 8, which enclose an angle of 30 degrees. We use the area formula, which is half of A times B times the sine of the angle between them. So it's going to be a half of 6 times 8 times the sine of 30 degrees, which is going to be a fourth of 48, which is 12. So the triangle with sides of length 6 and 8 enclosing the angle 30 degrees has an area of 12. Find the area of a triangle with sides of length 5 and 4 enclosing an angle of size 150 degrees. Is that right? Well, that would be a half times 5 times 4 times the sine of 150, which is 10 times the sine of 150. Which is 5. So 5 is the area of the triangle with sides of length 5 and 4 enclosing an angle of 150 degrees. Yes, that's right. A triangle of area 20 has sides of length 8 and 10. Find the angle that those sides enclose. So 20 is equal to a half times 8 times 10 times the sine of theta. So 20 equals 40 times sine of theta. So sine of theta is equal to a half. And the acute angle there is 30 degrees. Hello. Find the exact area of an equilateral triangle with sides of length 4. Okay, so I believe that the answer is 4 root 3. Find the exact area of a triangle with two sides of length 6, which enclose an angle of 120 degrees. Okay, so the area would be a half of 6 squared times the sine of 120 degrees. So 18 times root 3 over 2, which is 9 root 3. So 9 root 3 is the area of the isosceles triangle whose two legs have a length of 6 and whose apex angle is 120 degrees. All right, section 4, solving triangle problems. Okay. Hello, mathematics. I'm sorry, just give me a second with this. Right, in triangle ABC, AB is 3, AC is 8. And angle is 60 degrees. Find the length of BC. Okay, so we have to use the cosine rule. So instead of me spelling it out, I'll have to just work it out because the two-letter notation is too clumsy to articulate. But with that said, it would be well, it would be 73 take wouldn't it be 73 take 24? Yes, it would be that. And that is 49. And so the answer is 7. So 7 is the length of BC in the triangle ABC, where AB is 3 and AC is 8 and angle A is 30 degrees. Okay, find the exact area of that same triangle. So we're going to say that it's half of 3 times 8 times the sine of 30, which is 1/4 of 24, which is 6. So 6 is the area of triangle ABC, where AB is 3, AC is 8, and angle A is 30 degrees. A triangle has sides of length 7, 24, and 25. Find its largest angle. Now, because 7 squared is 49, 24 squared is 576, and 25 squared is 625, and 576 add 49 is 625. And therefore, the largest angle is 90 degrees. A parallelogram has sides of length 6 and 10, with an angle of 150 degrees between them. Find its exact area. Alright, so we're going to use, this time, 6 times 10 times sine of 150. 6 times. rather 60 times a half, which is 30. So the answer should be 30. So 30 should be the area of the parallelogram with sides of length 6 and 10 and an angle of 150 degrees between them. A ship sails 9... Oh, goodness me. Let me try that again. A ship sails 9 kilometers north, then 6 kilometers on a bearing due 120 degrees of north. Find its exact distance from its starting point. Okay, so we can visualize a triangle here, with sides of length 9 and 6, and the angle between them being 60 degrees. And then we just need to find the length of the third side. And we're going to use the cosine rule. Cosine of 60 is a half, by the way. So that would mean that, let's say, d squared is equal to 81 add 36, take 2 times 9 times 6 times the cosine of 60 degrees. Now 81 and 36 is 117, and then we have to do 117, take 108, rather 117 take 54, and 117 take 54 is 63. So it could be 3√7 kilometers, but let's just check again. So it sails 9 kilometers due north, and then 6 kilometers on a bearing of 120. And so we can clearly visualize that triangle with sides of length 9 and 6, with the angle of 60 degrees between them. And by the cosine rule, so d squared is equal to 9 squared at 6 squared, take 2 times 9 times 6 times the cosine of 120, times the cosine of 60 degrees. And that's obviously a half. (81 at 36 is 117. So 117 take 54. Yes, that's 63. All right, so I guess it is that. In my mind. I don't know for sure. Section 5. Graphs of sine, cosine, and tangent. State the value of cosine of 180 degrees. Okay, that would be -1. So -1 is the value of the cosine of 180 degrees. State the period of y equals tan of x in degrees. The answer is 180 degrees. 180 degrees is a period of y equals tan of x in degrees. State how many solutions sine of x equals a half, state how many solutions sine of x equals 0.5 has for 0 degrees is less than or equal to x, which is less than or equal to 360 degrees. Okay, that has exactly 2 solutions. And those solutions are 30 degrees and 150 degrees. So yes, sine of x equals 0.5 has 2 solutions in the interval 0 degrees to 360 degrees inclusive. State how many solutions cosine of x equals 0 has for x between 0 and 720 degrees inclusive. Alright, so the answer to that is 4. And those solutions are 90, 270, 450, and 630. So 4 solutions, 90, 270, 450, 630, for cosine of x equals 0, for x ranging from 0 to 720 inclusive. State the exact value of sine of x, state the exact value of sine of 210 degrees. The answer is negative a half. So negative a half is the exact value of sine of 210 degrees. Okay, next section is transforming trigonometric graphs. State the greatest value of y equals 3 times sine of x all plus 1. Multiplying sine of x by 3 multiplies the greatest value by 3, and then adding 1 to the entire function adds 1 to it. And thus the answer is 4. So 4 is the greatest value of y equals 3 times sine of x all plus 1. State the period of y equals cosine of 3x in degrees. The period of y equals State the period of y equals cosine of 3x in degrees. The period of y equals cosine of x is 360 degrees. Multiplying the argument by 3 divides the period by 3, and thus the answer is 120 degrees. So 120 degrees is a period of y equals 3. 120 degrees is a period of y equals cos 3x. State the smallest positive x-intercept of y equals sine of x takes 60 degrees. Subtracting 60 degrees from the argument translates the whole graph 60 degrees to the right. Now, doing that does not introduce an earlier root. because the earliest root, well, actually, beg your pardon, it actually does. Because I'm not thinking of it correctly. The answer is 60 degrees. 60 degrees is the smallest positive x-intercept of y equals sine of x takes 60 degrees. State the smallest possible value of x for which y equals tan of 2x is undefined. Multiplying the argument by 2 will bring the vertical asymptote twice as close to the axis. Usually it's at 90 degrees, and now it's going to be at 45 degrees. So 45 degrees is the smallest x value for which y equals tan of 2x is undefined. State how many solutions sine of 3x equals 0 has for x between 0 degrees and 360 degrees inclusive. Okay, so multiplying the argument by 3 has the effect of compressing it by a factor of 3, and thus we get like 3 times as many solutions in that interval, and they are well, there should be 7 of them. There should be 7 of them. Yes, there should be 7 solutions of y equals sine of 3x in the inclusive interval 0 to 360 degrees. Hello. Alright. And now we have to check. Oh, beg your pardon. It was actually exclusive. Other than that, that was totally fine logic and thinking. So really, only 2 actual mistakes. So 28 out of 30, which is not bad at all. Okay, so chapter 10 is coming up next, and that will be really hard.